Hi, it's Rob. Welcome to the second video in the Cumulus Cycles Kubernetes playlist. In this video, we'll get a brief introduction to what Kubernetes is, discuss its architecture, and take a look at some components you'll need to be familiar with when working with Kubernetes. If you're already familiar with foundational Kubernetes concepts and want to jump into the good stuff and start working with Kubernetes, you may want to head over to the next video in the playlist. Okay, if you're still with me, let's talk about what Kubernetes is. Originally developed by Google and codenamed Borg, Kubernetes is now managed by the Cloud Native Computing Foundation. At its core, Kubernetes is a portable, extensible, open source platform for managing containerized workloads. So it's a container orchestration tool which provides for high availability and scalability of application infrastructure. Applications managed by Kubernetes are deployed in a Kubernetes component called a cluster. And a cluster is made up of nodes, which are basically servers or VMs. A cluster has at least one master node, and the master node runs the Kubernetes API server, which allows for interaction with the Kubernetes cluster. It also runs the control manager or control plane, which manages container lifecycles. Additionally, the master node has a scheduler which deploys resources on the worker nodes, and it runs an etcd process which manages the state of the Kubernetes cluster. In addition to the master nodes, a cluster also has several worker nodes, and each worker node has a kubelet process running on it, which provides management of the containers running in a pod on a node. The worker nodes are where the Docker containers are deployed to, and the containers are deployed into pods. Pods are the smallest deployable units of compute that you can create and manage in Kubernetes. They typically have one pod per application, but there may be instances when you run multiple containers in a pod, such as a logging or monitoring application running alongside your main application container. Each pod in a cluster is assigned its own IP address and can communicate with other pods in the cluster via the Kubernetes virtual network. It's important to note that pods are ephemeral. They can die and be replaced. So the IP addresses assigned to the pods change as the pods are spun up, die, and replaced. So Kubernetes has a component called a service, which is an abstract way to expose an application running in pods as a network service. So a service is used to provide permanent IP addresses, which we can use to interact with the pods. The service also load balances requests to the pods. So as new pods are spun up, their IP addresses are registered with the service, and requests to the pods are managed through the load balanced service. Finally, each node has an Ingress component installed on it, which handles requests into the application. It's the Ingress which forwards requests to the service, which will load balance the requests to the pods. And all of these components are replicated to provide for a highly available and scalable application architecture. So that's a brief overview of Kubernetes. As you can see from this page, there's a lot more to Kubernetes than that. So I encourage you to head over to the docs and give them a read through if you'd like to take a deeper dive. Now, with the theory out of the way, it's time to start working with Kubernetes, and we'll do that in the next video. I hope to see you there.